Hi everyone, a warm greetings to all. Myself Dr. R. Prema Sumadhi, Assistant Professor in the Department of Mathematics, SRM Madurai College for Engineering and Technology. Let me learn some introduction about graph theory. We learn about the basic definitions, some types of graphs, terminology, representation of a graph, subgraphs, connectivity, Hamiltonian, and Euler definitions. See, a graph is a generalization of simple concept of a set of dots, we say points or edges or arcs. In other words, it's a representation. A graph G is equal to V comma E consists of set of vertices denoted by V or by V of G. Here G is mentioned by the graph, and the set of edges E or E of G. That is, a graph G is an ordered triple V of G, E of G, pi consists of a non-empty set V called the set of vertices, that is nodes or points, of the graph G, and E is said to be the set of edges of the graph G, and pi is the mapping from the set of edges E to a set of ordered or unordered pairs of the elements. There are two types of edges here, directed edges and undirected edges. Ordered pair of vertices represents us here U comma V, directed from vertex U to V. It is directed. Suppose it's to be undirected means unordered pair of vertices. Represented as U comma V disregards any sense of directions and treats both end vertices are interchangeably U comma V or V comma U. Okay. The next, loop. A loop is an edge whose endpoints are equal, that is the starting and the end points are both are equal. An edge joining a vertex to itself is called a loop, represented by U comma V U, because the starting and the end points are same. So U comma U is equal to U. So it has some loop, look like that, and multiple edges, two or more edges joining the same pair of vertices. Here let us see the graph U V connected by two edges E1 and E2. So a pair of vertices connected by more than one edge, it's called multiple edges or parallel edges. Graph type. Let us see some simple graph or undirected graph. Consists of V, empty set of vertices, and E is a set of unordered pair of distinct elements of V is called an edges, that is undirected. See, let us see the example. Here G of V comma E. In this graph there are three vertices U, V, W. They are connected by the edges, three edges, that is first edges U comma V connected by one edge, and V comma W connected by one edge, and U comma W connected by one edge. Here there is no direction and no loop. So any graph without loops and multiple edges, it is called a simple graph. Okay, simple graph or undirected graph. Next, multigraph. In this multigraph, the set of vertices V and the edges set and a function f from E to U comma V. Here let us see the example. Here 3 points are there, U, V, W, and the edge sets are E1, E2, E3. See, here U and V connected by more than one edge, that is E1 and E2. U, V joined by E3. So in this three vertices graph, particularly U and V connected by more than one edge, that is multiple lines are included here. This types of graph is multigraph. Pseudograph. For any graph consists of set of vertices and edges are there. Here also 3 points is there, and U and V connected by two edges E1, E2, and B and W connected by an edge E3. Particularly the vertex W having a loop E4. We already know that loop is the starting and end points are itself, it's a point. So E4 is an edge, both are the starting and end points are the same as the vertex W. So a graph having multiple edges and a loop, it's called pseudograph. Definition of directed graph. In this graph, the set of vertices V and the edges set is E the ordered pair of elements of V, directed edges. Let us see U to V and V to W. Let us see the direction. Arrow marks is here. So it's directed V to U. So the edges not only connected by the vertices not only connected by the edges, it also implies the direction from where to where. So it's a directed graph. Let's see the definition of directed multigraph. We already see that multigraph means it a pair of vertices consists more than one edge and along with loop. Here this multigraph, all the edges mention the direction also. So this is directed multigraph. See, in this graph, the vertices sets are U, V, W and the edges sets are E1, E2, E3, U4. You having loop and the multi edges are connected with U, again U, both U, V, W here. Next, see the terminology of undirected graph. Suppose in a graph U and V are adjacents, means if U and V is an edge, E is called incident with U. Here let us see the graph U and V having an edge, that is U and V are connected by an edge, means these 2 points are adjacent points, and the edge connected by the U and V is incident with U, that edge incident with V also. That is the terminology of adjacent and incident. Called the U and V are called the end points of this particular edge. Next, degree of vertex. The number of edges incident on a vertex. How many edges are incident in a particular edge, vertices, that counting is called the degree of a vertices. Suppose a loop. A point having a loop means it's given to the number of 2, particularly for the loop. Pendant vertex. You know the pendant vertex? It has a degree of 1 only. Suppose a point has no edges, means it's also a graph. That graph is, that particular vertex is named as isolated vertex. That particular point only here. There is no here. Adjacent is empty. So this vertex is particularly called isolated vertex. That isolated vertex having the degree of 0. So let us see this example for the simple graph U, V, W and K is some isolated vertex. Here the degree of U is that particular point incident with 2 edges. So degree of U is 2. Degree of V is equal to 1. And the same degree of W is equal to 1. Then what about degree of K? It is an isolated vertex. Here edges is empty. So degree of K is equal to 0 because K is isolated. Let us see the terminology of directed graph. For the edge U, V, U is adjacent to V or V is adjacent to U from V. U is the initial vertex and V is the terminal vertex. In that, in degree, out degree. Let us see means in degree. In degree means the number of edges for a particular point is a terminal vertex. It is denoted by degree of U minus. Suppose out degree means it's denoted by degree of plus U. The number of edges for which U is a initial vertex means it has in the plus sign. Terminal vertex means it has, the particular point has a degree of minus degree. Let us see this example U, V, W directed graph. Particularly the directed graph only we mention in degree, out degree. So here degree of U minus is equal to 0. Why? Here U is the terminal vertex from U to V. Suppose degree of U is equal to 2 in the sense of plus, because the 2 edges starting from U to V and U to W. In this sense, degree of V minus V is equal to 1 and degree of plus V is equal to 1. Because that particular point look forward from U to V and V to W. So plus is equal to 1 in the sense of minus also equal to 1. Degree of plus U is equal to 0. Let us see some important theorem. That's a name handshaking theorem in undirected graph. See, you know how to calculate the degree of vertices. Suppose in a graph, or the summation of all the vertices, which is equal to the 2 times of that edges of in that graph. Why? Why 2 times means 2e. That is the edges in the multiplied with 2. That is the answer of the all the summation of degree of vertices in that particular graph. That is every edge connected in 2 vertices, that is 2e. The summation of degree of all the vertices of a undirected graph is always 2 times of the edges of the given graph. Let us another one graph deal with undirected graph. An undirected graph has even number of vertices with odd degree. Suppose the vertices sets, some vertices has some even degree, some vertices has some odd degree. So we have to split V1 and V2. In this way also, the total degree of vertices is equal to 2e, because the degree of V can be split into V1. V1 is the summation of even degree vertices and V2 is the summation of odd degree vertices. So degree of V is an even for V belongs to capital V1. The first term in the right hand side is the inequality is even. See the total also 2e. In this right hand side the first part also even degree. So automatically the right hand side second part, that is the degree of V where V belongs to V2, the last two terms is also, if you add the odd number of in 2 times, is also even. So the right hand side first part also even and the second term of the right hand side last two terms also even, means totally we add together it's also even degree, that is equal to 2e. So in any undirected graph has even number of vertices with odd degree. Let us see some special cases. Complete graph is always represented by Kn. It's a simple graph that contains exactly one edge between each pair of distinct vertices. Here see, it is always noted by Kn. Here n is represented by the number of vertices included in that particular graph. Here K1 is equal to 1, K2 is equal to 2, means that is 2 vertices, K3 and like that. And some special cases, another one cycle represented by Cn. Here n is always strictly greater than or equal to 3, because C3 is, let us see 3, the graph having 3 vertices and 3 edges. It consisted n vertices but always started with greater than or equal to 3 only. The edge set is V1 to V2, V2 to V3, like that we have to calculate it. Particularly the last edge vertices is Vn, V1. The starting and end vertices should be connected in a cycle. Next, some wheels Wn mentioned by the first letter obtained by adding additional vertex Cn. We know that Cn is a cycle graph, and connecting all the vertices to this new vertex by new edge. See, without in W3, let us see the example. In W3, without the center vertices and connected by the 3 vertices, it's a Cn graph. Cn means cycle graph. Now we have add one new vertex in the center point and connect the center point to the Cn all the vertices, so that included in the center vertex connected by new 3 edges, that is W3. Let us see W4. The outer vertices are 4 edges and 4 points. We have to add a new vertex in the center and connected with the 4 edges to the outer vertices. So we have to adding additional vertex to the cycle graph and connecting these additional vertices to the previous vertices by new edges. And bipartite graph, it is a simple graph. Here we have to partition the V in 2 disjoint sets, in the sense V1 and V2, such that every edge in the graph G connect your vertex V1 to the another domain of disjoint set of V2. There is no edge included having their connection, only V1 to V2 vertices. Yes, representation for this example, let the V1 set having the vertices V1, V2, V3 and the another disjoint set of V2 from V, that is V4, V5 and V6. There is no vertices connect in the same domain. That is one complete bipartite graph. It is represented by Kmn. Is a graph that has its vertex set partitioned into 2 subsets of m and n vertices respectively. This is also both disjoint vertices. In this graph, there is an edge between the 2 vertices if and only if one vertex in the first subset is connected with all the vertices with the second subset. The first subset means in the sense of V1 and the second subset means in the sense of V2. So here KMN, that M is represented for the first vertices and N is represented to the second vertices set. Here K2, 3, the 2, 3 is represented here totally 5 vertices. The first vertices V1 having 2 vertices points and the second set K2, 3, here 3 is the second vertices of V2. So the first vertices V1 points connected with all the vertices of V2 in or each vertices connected with all the vertices of another set. Here K2, 3. Here K3, 3 means that sets V1 and V2 both are having 3 set of points. This is complete by subgraphs. A subgraph is a graph G. We have to construct a new graph H from G. Here we have to differentiate the vertex set and edge set by B dash, E dash, where B dash is a subset of V and E dash is a subset of E. See this example. See here G, and we have two subgraphs H1 and H2. This is also the vertices set UVW and U2V. In this way we have to generate some. Thank you for your attention.